Hit the record button and we'll hit this button. Okay. Today we're going to talk about exponents. I know all this is a review for you, but we have to make sure everybody's on the same page here. If we have b raised to the e, the b is called the base number, and the e, of course, is the exponent. Bonent. Everybody remember this? Can y'all see that okay?
I can't see anything.
Same here.
You cannot?
No, there's nothing on the screen.
Oh, damn. How about now?
I still
No.
don't see anything.
No.
Does anybody see anything?
No.
No,
No.
No, I don't see anything either.
No.
Oh, damn.
nothing.
I mean,
No.
I just see the icon that you're like trying to share, but I don't see your screen.
Okay, let's see. What in the world? Video settings. How about now?
Nothing.
No.
Uh, oh, man. Ah, how about now?
Yes.
Yeah, you're up now.
Is that it? Okay, I'm sorry. I have to relearn this stuff. I'll tell you how bad my memory is. I went in the bathroom the other day, forgot why I went in there. It's not funny. Okay, exponents. Can y'all see this okay? B is
Yes.
called the base number. The little number up here is called the of course, the exponent. So if we have 5 squared, you never multiply these two numbers. What this means is how many times do we multiply the base number times its own self? That's what my ex-wife would say, by its own self. So we do it times itself twice. And of course, 5 times 5 is 25. If you don't have one, go and buy one of these. It's not a graphing calculator, but it is a scientific calculator. And this is about $10 or $12. They're very inexpensive. First, you turn it on, and you put 5. And here, this little hat-looking thing right here is raised to. Of course, that one's squared, but raised to the second power. See, you've got 2 lines on here. The first line is it shows you what you entered in here, and the second line is it shows you the answer. This is very helpful because you ladies have long fingernails. You guys have big fat fingers. You're going to hit the wrong keys. You got to have fingers like a spider to work one of these things. So anyway, and these scientific calculators will do order of operation for you. So hallelujah. Now the product rule, that's what an exponent is. The product rule, did y'all get one of these in your email?
Yes.
You should
Yes.
have. Yeah. Okay, I think you'll find that this may or may not be handy. The product rule is if you have a raised to the m power times a raised to the n power, if you'll notice the base numbers must be the same here. So what do we do with the exponents? If you have the same base number, this is going to be a to the m plus n, you just add the exponents. So if we have 3 squared times, now this only works for multiplication, ergo the name product rule, times 3 to the 5th power, that would equal 3 to the, and we add these two to the 7th power. And again, you can put this in your handy dandy calculator and it'll spit out the answer. Everybody okay with this? Okay, real simple. Hopefully you remember this from 7th grade. Now the power rule, is if you have a power raised to a power. So if you have x to the m power, all raised to the n power. Okay, you have a power raised to a power. This is x to the m times n. So if you have 4 squared raised to the 5th power, now we multiply these two powers, 4 to the 10th power. Excuse me. And if you put this in your handy dandy calculator, make certain that you put these in parentheses. Okay. I'm going to go real fast, so tell me if you need me to slow down. Okay, now the quotient power. This is the power rule here also. Power of a quotient. So if you have a over b all raised to the e power, this would be, now what we're going to do is we're going to distribute this e over every term in here. So it's going to be a to the e over b to the e. Okay? And these problems, they really don't get any more difficult. They just get longer. Now, if you look back up here, the product rule, if we're multiplying, what do we do with the exponents? We add them. Now, what do you suspect we're going to do if we have a quotient, if we have division, if we have x to the a over x to the b? Again, we have to have the same base numbers. Now, the product rule, if we're multiplying, we added the exponents. So what do you suppose would happen if we're dividing?
Subtract.
Excellent. We subtract. So it's going to be x to the a minus b, not b minus a minus b. And this is why. If we have, let's say, 4 squared divided by, 4 to the 5th power, I'm sorry. 4 to the 5th over 4 cubed. Now, what does this mean? Let's expand this. It's 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. Right? Right. Divided by 4 cubed, which is 4 times 4 times 4. Now, what's any number divided by itself? 1. Right? So we can just eliminate that, and eliminate that. And what are we left with in the numerator in the top? 4 squared or 16. So what's our rule here? 5 minus 3. Okay, everybody with me? Okay. Now, get this if you're so smart. Now, if we have this, if we say we have 5 cubed divided by 5 cubed, let's see, who's here? Miss Almeida, are you here? No. Miss Barber? No. Mr. Braxton? Miss Caballero, I know you're here.
Yes, Professor.
What's 5 cubed divided by 5 cubed?
1.
Excellent, 1. Now look, what's our rule here? When we're dividing and we have the same base number, have to have the same base number. So this is 5 to the 3 minus 3, which is, excuse me, I think I got the COVIDs again. 3 minus 3 is, see, 3 birds on a wire, 3 of them fly away. So this is 5 to the 0 power, which is, this is one of those things you're going to have to remember. Okay, 5 to the 0 power. Before I forget, the final exam is in December. Sorry, December. You must make a 50% or more to get credit for this course. Otherwise, you have to do all this misery all over again. But if you have any number to the 0 power, the answer is 1. One of the questions you're probably going to get on the final is this. You're going to get 3x squared minus 2y to the 4th. Real long thing here. Come on, boy, think. Plus 3z to the 5th, blah, blah, blah. All raised to the 0 power. So what is this, Miss Cedillo?
Yes, it's 1.
1. Is that what you said?
Yes.
Excellent. 1. Right? Now, what do the parentheses do? Makes this one number. Right? Right. And you raise that to the 0 power, and it is 1. Very good. Okay. Now, this is what we're going to talk more about today. First, let's drink. And that is negative exponents. Sounds horrible, doesn't it? It's not. It's not bad. Oh. Vodka. Now, don't go running to Dr. Martin. That boy's drinking vodka during class. He's not supposed to be drinking. Please don't do that. I'm in enough trouble with her as it is. Okay. If we have a to the negative n power. Don't you love all these letters? What moron Yankee comes up with this stuff? Okay, what do we do here? This is actually over 1. We just don't write it because we're lazy. Now, if the exponent is negative, move it. If it's in the numerator, take it to the denominator, and then it becomes positive. So this is going to equal, we're going to move this to the bottom, and the exponent becomes positive. Now, what's in the numerator? Miss Chavabo, are you here? Miss Clifton? Miss Galagoda? Mr. Garcia, I know you're here. Don't hide.
I'm here.
What's in the numerator?
1.
Excellent. 1. Right? Very good. Okay, so what if we have this? Now, these problems, they really don't get any more difficult. They just get longer. So if we have this, if we have a to the minus 5 over b to the minus 3. Now look, don't try to do it all in one step. Take it one at a time. Let's see, whose turn is it? Ms. Hardy? Are you here? Yeah, I know you are. I can see you. Miss Hardy. Miss Caballero, punch Miss Hardy. Tell her to wake up.
To whom? Sorry.
Okay, what do we do here? When the exponents are negative, what do we do?
We changed them.
Good, we move them. I like to draw the fraction bar first because I'm stupid and I have to do that, otherwise I'll get confused. Where does a to the minus 5 go?
To the bottom.
Excellent. A, and then it becomes positive. B to the minus third.
Does it goes up or we
Good.
have to
Yeah,
make it step by step?
That's right, it goes up. If the exponent is negative, move it. If it's in the numerator, put it in the denominator. If it's in the denominator, move it to the numerator. Okay, so this is going to be b cubed. Is there anything else we can do here? No. We can't subtract the exponents because we don't have a common base number. So this is our answer. Am I right or am I right? I'm right. Oh, what we also have to say here is that a cannot equal 0. We cannot have zeros in our denominators. That's going to come to play more a little bit later. Let's have a cough drop. What do you say? Well, I tell you, I had the COVID twice, as my ex-wife would say, and I had all my shots. I even had a rabies shot. No, I didn't have a rabies shot. And the first time I got it, boy, I had this horrible pain in my neck and my shoulders. Terrible. I know what Miss Caballero is saying. Good, you deserve it. Weren't you saying that?
No, Professor. I was
Uh-huh.
thinking about the time I got it.
Did you get it too?
Yeah.
How bad was it?
It was really bad. I was in bed like for 3 days.
Pobrecita.
Yeah.
Yeah. And you were thinking pobrecito for me, huh?
Yeah, sure.
Mm-hmm. Okay. Whose turn is it? Miss Hardy, you just went. Mr. Holloway, are you here? Mr. Hyson? Ms. Ignace? Miss Ignace, I know you're here.
Yes, I'm here. I've been having internet and Wi-Fi issues, so
You
I
know,
don't know.
Did you get any lightning over your house?
No, I don't think so.
Who is that that's talking? Well, I got it here, and I tell you what, my internet got knocked out for a little while. Okay. Who was that was talking and said they had internet problems? Mr. Hyson, was that you? Mr. Holloway? Who is it?
It was Maya.
Oh, it was. Ms. Ignace? Get this if you're so smart. Ignace to the -4 power. What you're going to see here, everybody listening, what you're going to see here are evaluate, EVALUATE, with all positive exponents. If y'all can't read my writing, you're not going to hurt my feelings. Tell me, say, boy, I can't read that. What does it say? Okay, so evaluate with all positive exponents. So Ms. Ignace, what are we going to do here? We have a negative exponent.
I don't know.
Please don't ever tell me I don't know. It means you don't care and you're not going to try. What do we do when the exponents are negative?
Make them a positive.
How? We move them. Okay, if it's in the numerator, this is actually over 1, we just don't write it. If it's in the numerator, if it's in the top, we move it to the bottom. If it's in the bottom, if the negative exponent's in the bottom, we move it to the top. So what's this going to equal? Take this one at a time. First, I draw the fraction bar because I'm stupid. So we need to move this. Where's it going to go?
The
To the
bottom.
bottom.
Good. And then the exponent becomes positive. Now what's in the numerator? What's in the top?
1.
Good. Anything else we can do here? Nope. Mr. Hyson, are you here? Mr. Holloway, are you here? Mr. Islam, how about this? 4 to the negative 2 power. What are we going to do?
Put the 4 on the denominator, so it'd be 1 over 4 to the second power.
Excellent. 1 over 4 squared. Now we can evaluate this. What is 4 squared?
16.
Good. Okay. Okay, you're not going to see a whole lot of this, but you are going to see some from time to time. Okay. Okay. Mr. Jimenez? Ms. Jones? Ms. Lewis?
Yes.
Okay, get this if you're so smart. 3/4, all raised to the negative 2 power. Okay, now look, take this one step at a time. This is called the power rule, right? We have, now the exponents here in the 3 and the 4 are 1. We just don't write it. So what are we going to do with that negative 2?
We're gonna make it a positive by moving it.
Yeah, ultimately we're going to do that, but the first thing we're going to do is we're going to distribute this negative 2 over every one of the exponents in here. So that's going to be 3 to the negative 2 over 4 to the negative 2. Right?
Mhm.
Right. Now what?
We did 3 minus 2, which is 1.
No. Now look,
Yeah.
is everybody listening? If the exponent is negative, is the exponent here negative?
Oh yeah, we're gonna
Yes. What are we going to do with this?
Move it to the bottom and flip it to a positive.
Good. So that makes it 3 squared. Take these, just take them one at a time. They're really very simple. Now, what do we do with the 4 to the minus 4?
move it to the top.
Excellent. And becomes 4 to the 4th power, which is, oh, you know what? I did those backwards. Stupid boy. Oh, wait a minute. This is supposed to be a 2 here. I'm so stupid. I'm sorry. I'll do better. No, I'm not going to do any better. Everybody see this? I'm sorry. I made a mistake.
Mhm.
So this is going to be 16 over 9, right? Gosh. Y'all should have caught me on that. Yeah. I did that on purpose. Yeah. Ms. Lewis, was that you?
Yes.
Ms. Luna? I'm sorry, Mr. Luna? No key. Ms. Martinez? No, Ms. Martinez. Ms. Nuguna, is that right? Are you here? No. Mr. Nunez? Mr. Nunez here? No. Ms. Power Wheeler? Are you here?
Yes.
Okay, if we have 5/6, all in parentheses, raised to the -2 power. What's the first thing we're going to do here? Now remember,
So it would be 5, but with the negative. And then the bottom would be 6 with the negative exponent, and then flip it.
very good. Okay, so what do we have in the numerator?
6.
6 squared. And in the denominator?
5 squared.
So that's 36/25. Is that right? Can we reduce that at all? Doesn't look like it. Very good. Ms. Vieira? Ms. Zaroli? Or Mr. Zaroli?
Yeah.
Okay. Over 4B. Okay. What's the first thing we're going to do here, Mr. Zaroli?
It's going to turn into a squared and 4b squared.
Okay, the first thing we're going to do is we're going to distribute the -2 over every term in here. So it's going to be a to the -2 over, and remember, all of these have exponents of 1. We just don't write it because we're lazy. Over what?
For 4b to the power of -2.
4 to the -2. Don't forget that has an exponent also. B to the -2. Now, how are we going to get this where all the exponents are positive?
You're going to move it. And it'll
Good.
be
A to the
and b
-2.
squared on top.
Okay. A to the -2 goes to the bottom to the denominator. 4 to the -2 goes to the top, right? And becomes positive. Same thing with the B. So this equals 16 B squared over A squared. Ms. Zavala? No, Ms. Zavala? Okay. Let me give you one. You're going to get something like this on the final exam. Again, they're not difficult, they're just longer. So if we have 5 B squared C to the -3 over 2 B to the -2 C squared, all raised to the -2 power. Whose turn is it? Ms. Almeida, are you here? No. Ms. Barber? Mr. Braxton, Ms. Caballero,
Yes,
No.
Professor?
I know you're here.
Yeah.
You're gonna be a troublemaker, aren't you? I'll send,
No.
I'll send you to the principal.
Why?
Oh yeah, we ain't got no principal. Okay. First thing you want to do here, this is not difficult. It looks horrible, doesn't it? Well, the first thing we want to do is distribute the -2 over every exponent in here. So it's going to be 5 to the, come on, Miss Caballero, I'm about to die of old age up here.
Oh, sorry. -2.
Good. B to the,
-4.
excellent. We have -2 times a +2 is a -4. C to the,
-6.
ah,
Oh, no. 6.
good.
Right?
To the +6 power, right? Negative times a negative is a positive. All over 2 to the,
-2
good. B to the,
to the 4th.
good. And C
And
to the,
-4.
good. Everybody see why we're multiplying -2 times all of the exponents. Now, take them one at a time. If the exponents are negative, move them. If they're positive, leave them where they are. Where does 5 squared go?
Down.
Good. And becomes positive. B to the -4,
Also down.
also down, good. And C to the 6,
It stays there.
excellent. Now, 2 to the -2,
Goes above.
good. And that's 2 squared. B to the 4th,
Stays there.
good. Stays at the bottom because the exponents are already positive. C to the -4,
Goes up.
good. And that becomes positive. Now, remember, when we have the same base numbers like we do here, here's a C and here's a C, what do we do with the exponents? We add them, right? That was the product rule. Okay, when the base numbers are the same, we add the exponents. So that's going to be C to the, what is that? 6 plus 4, I'll carry the 7, 30 days, that's September. 10, right? Times 4. Okay, 2 squared is 4. 5 squared is
25.
25. Now we have b to the 4th times b to the 4th is?
B to the 8.
Good. Is there anything else we can do here?
No.
Nope.
No, we can't.
Okay, what we typically want to do is put the constant in the front. I'm not real wild about it. I really don't care. 25b to the 8th. Okay, this is about as difficult as these problems get, and it's really not all that hard. They're just take them one at a time. You know the rules. Mm-hmm. Mm-hmm. Okay. Done did that. Mm-hmm. Mm-hmm. And we've only been in here about 30 minutes. It seems like we've been in here about 4 or 5 hours, doesn't it? Okay. Miss Cedillo, did you come in?
I did.
You ready?
Okay.
Okay. We have 7 x to the -3 y squared over 2 to the minus 1 and you look at this and you think, oh my God, I can't do this. Just take it real slow, take it one at a time. If the exponents are positive, leave them where they are. If the exponents are negative, move them. So where does the 7 go?
At the top.
Good, because the exponent there's 1, we just don't write it.
Mm-hmm.
X to the minus 3,
Goes down.
good. And the exponent becomes positive. Y squared,
It stays up.
good. Y squared, 2 to the minus 1,
Goes up.
good. Times 2. X squared,
Stays down.
good. And y to the minus 5,
Goes up.
good. Okay. Now, all this is multiplication. There's no pluses or minuses. So we have 7 times 2 is 72. I mean 14. Yeah, I knew that.
14.
Now we have y squared and y to the 5th with the common base numbers. So what do we do with the exponents? Add,
You add.
right? And where did this x come from?
It was at the top. Or no.
That's
I
this.
think it's
That's
supposed
a
to be
Y.
squared.
That's supposed to be squared, right?
Yeah, squared.
It cannot be more stupid.
No, we all have our days.
We got all these.
X5.
That went up. That stayed. Y to the, okay. So we have y squared times y to the 5th is y to the 7th, right? Everybody see this? We have common base numbers, so we add the exponents. And what's this one if you're so smart?
X5.
X to the 5th? Is that what you
Yes.
said?
X to the 5th.
I knew that. I knew that. Yes. Very good. Anything else we can do?
Nope.
Nada. Okay, when you get these, and you're not going to see these a whole lot, but they're going to irritate you with it on the final. Okay. There are 4 properties of multiplication. I'm only going to irritate you with one because it's so important. Very, very, very important. Super duper whiz bang important. So if we have now what do the parentheses do? It makes this one number. So we're going to multiply the 3 times everything in here. Oh, before I forget, there's a nice pretty quiz on D2L. Okay? So we're going to multiply the 3 times everything inside here. Very good, Miss Cedillo. Miss Shababo? Miss Clifton? Miss Galagoda? Mr. Garcia? Get this if you're so smart.
All right.
We're going to multiply, excuse me, we're going to multiply the 3 times every term in here. 3 times 2a is?
All right, that'll be 6a
Good. Don't forget the plus.
plus 15.
3 times 5 is?
15b.
Good. Can we combine these things?
No.
No, not like terms. Okay? Distributive property of multiplication, super duper whiz bang important. They're going to get longer, but they really don't get any more difficult. Whose turn is it? Ms. Hardy? Get this if you're so smart. 5c squared times 3c plus 2. 3c plus 2. Okay, first of all, 5c squared times 3c is what? Miss Hardy, you with us? She didn't want to play. Mr. Holloway? Mr. Hyson? Well, I know one of you two guys is here. Oh. Huh. Okay. Let's see. Ms. Ignace? We're going to take 5c squared and we're going to multiply it times everything in here. First of all, what's 5 times 3?
15.
Good. Now we have c squared times c. The exponent on the c is 1. We just don't write it. So what's c squared times c?
C squared.
What do we do with the
C
exponent?
squared.
3 cubed. Remember, when the base numbers are the same, we add the exponents.
Oh.
Right? Okay. Now we have 5c squared times 2 is 10c squared. Right? Right. Did everybody see why this is c cubed? Remember from our exponent rules?
Yep.
When the base numbers are the same, we add the exponents. Very, very important. Okay. Who's next? Mr. Islam, if we have negative 4d cubed times negative 6d squared minus 5d plus 3. See, these problems, they really don't get any more difficult, they just get longer. So first of all, we're going to take the 4d cubed and multiply it times everything in here. What's negative 4d cubed times negative 6d squared?
24d to the 4th power.
To the 5th power.
Oh, sorry, 5th.
Okay.
Oh, 3.
3 and 2. Okay. But you're right. The most difficult part here was negative 4 times negative 6, and you got that right. 24, right? Negative 4 times negative 6 is a positive 24. D to the common base numbers. So we add the exponents. 3 and 2 is 5. Now we have negative 4d cubed times negative 5d is
20d to the 3rd power.
good. 20d to what?
The 3rd.
4th. This is 3. This is 1.
Oh, it's 3. Sorry, I thought it was 2.
I'm sorry. That's my lousy handwriting. Sorry.
No worries.
Okay, now we have negative 4d cubed times 3. I'm sorry. A negative times a positive is a
Negative
good. 12.
d to the 3rd.
Good. Excellent. Is there anything we can combine in here? In order for us to be able to combine the d's, they have to have the same base numbers, which they do, but they also have to have the same exponent. Okay, same base number, same exponent, and they do not. Now, the way that we have it here is the correct way to do it. I really don't care, but you're going to find somebody in your math career who will want this in the correct order. Largest exponent first. Okay, and we have that. Right, right. Very good. Okay. Mr. Jimenez, are you here? Ms. Jones? Ms. Lewis?
Yes.
Are you there?
Yes, I'm here.
Okay. Now, that's when we had one number multiplied by all these other numbers in here. But what if we have two numbers? 2a plus 4 times 3a plus 5. What the heck are we going to do here? Okay, it's real simple. Okay. First, we're going to take the 2a and we're going to multiply it times everything over here. Then we're going to take the 4 and multiply it times everything over here. Okay, so 2a times 3a, get that if you're so smart.
6A.
Ah,
A.
6a squared, right? Base numbers are the same, so we add the exponents. A times a is a squared. Now we do 2a times 5 is
10A.
10a, good. Okay, now we finished distributing the 2a times everything over here. Now we do the same thing with the 4. 4 times 3a is
12A.
good. And 4 times 5 is 45? 20. Is there anything else we can do? Anybody? Anybody see it?
You could
The
add the
20.
A.
Combine.
Good. The middle two terms, when you do these, when you have two numbers here, you typically have the same common numbers, excuse me, like terms in the middle. This is called the linear term. So we have 6a squared, 10a's and 12a's are 22a's plus 20. Everybody see that? These are like terms here. Anything else we can do? Okay, let's do one more. I can feel y'all's head throbbing from here. Mr. Luna? Ms. Martinez? Mr. Nunez? Miss Power Wheeler? Is it just power or is it Power Wheeler?
Either or.
Okay. Do you prefer one or the other?
You could just call me Power.
Okay, Miss Power, what if we have this if you're so smart? Negative 3b, got all these godless negative numbers, times 4b minus 6. Okay, again, we're going to take the first term and multiply it times everything over here. Negative 3b times a positive 4b is?
Negative 12B squared.
Oh, 2, good, excellent. Negative 12 b squared. Now negative 3 times, I'm sorry, negative 3b times a negative 6 is?
18.
Positive 18b, right? Don't forget the b up here, up in here. Okay, now we finish with this. Now we do the same thing with the negative 2. Negative 2 times 4b is?
Negative 8B.
B, right, good. And negative 2 times negative 6 is? Right, negative times a negative is a positive. Positive 12. Anything else we can do?
Combine.
Excellent.
The middle.
Good, very good. We can combine like terms, so we get negative, come on, stupid boy, negative 12b squared. 18b's minus 8b's are a positive 10b. Is that right? My brain just slipped out of gear. Plus 12. Is that correct? Okay, be sure, and I don't, oh, see, I didn't see y'all Tuesday, so to me, it's very important to show your work. When Moses came down from Mount Sinai, he had 15 commandments. The 11th commandment was he tripped and fell and broke one of the tablets. The 11th commandment was, thou shalt show thy work. If you don't show your work, I have nothing to, no recourse other than to count it wrong. But if you make an arithmetic mistake, I'll be understanding. I know it sounds stupid, but procedure is very, very important. I know the answer is important too, of course, but the procedures, I hate to say more important, but it's just as important. Are there any questions? Okay.
No.
All right. Okay, we're going to stay with 7 o'clock if that's okay with everybody. Y'all take care. Have a good weekend. Que tengas un buen fin de semana. I don't know what that means, but sounded Spanish.
Gracias.
Igualmente, gracias. I don't know what that means either. Okay, y'all take care. Have a good weekend. I'll see you Tuesday. Don't forget the quiz.
Bye,
Bye.
Mr. Bond.
Bye, Professor.
Bye-bye.
Thank you.
Adios.
Thank you.